Welcome back, everyone. Ready for another deep dive?
Always ready for a cosmic adventure.
Well, today we're setting our sights on something pretty spectacular.
Let me guess. Are we talking about the Heart Nebula?
You got it. That giant glowing Valentine in space.
Ah, the Heart Nebula, or IC 1805, as it's officially known. It's a real showstopper.
Definitely a favorite for astrophotographers. But we're going to go beyond just the pretty pictures, right?
Absolutely. We'll uncover the science behind the beauty, how stars are born within it, how they live out their lives, and even how they eventually die and give back to the universe.
It's about 7,500 light years away, right?
That's right, nestled in the constellation Cassiopeia.
So first things first, can we just talk about how it glows? I mean, it's a cloud of gas and dust, so what's making it light up like that?
Well, it all comes down to those hot young stars tucked inside the nebula.
Ah, so it's more than just stars being there. It's something they're doing.
Exactly. It's their intense ultraviolet radiation. Think of it like this. Those stars are so energetic that they strip electrons from the hydrogen atoms in the nebula,
Okay, and that creates...
a glowing plasma. And since hydrogen is, well, everywhere in the universe, it's the light we see most prominently. That's why the Heart Nebula has that striking red hue, mostly due to something called H-alpha emissions.
H-alpha emissions.
Yeah, it's a specific wavelength of light that energized hydrogen emits, kind of like its signature glow.
So it's not just any light. It's a specific kind of light from hydrogen that makes it so red.
Exactly. It's like a neon sign, but on a cosmic scale.
And speaking of the nebula's appearance, you see those dark lanes and those incredible pillars in the images. I mean, what creates those shapes?
Ah, those are sculpted by the powerful stellar winds coming from the stars, especially the ones clustered in a group called Malot 15.
Malot 15, that's at the heart of the nebula, right?
Right in the center. It's a group of really young, massive stars, just a few million years old.
Babies, in cosmic terms.
Exactly. And they're already throwing their weight around, so to speak. Those stellar winds act like cosmic chisels, carving out cavities in the nebula and shaping the gas and dust around them.
So those dark lanes, that's actually less material, like it's been blown away.
You got it. Those stellar winds are powerful, but they're nothing compared to what happens when those stars reach the end of their lives.
You're talking supernovae,
Right.
exploding stars.
That's right. And these massive stars in Malot 15, they're destined for a truly spectacular exit. They don't just fade away, they explode, scattering the elements they've created throughout the nebula.
It's almost poetic. They create these incredible structures with their energy, and when they die, they seed the nebula with the ingredients.
For everything. Planets, new stars, even life itself. You could say the Heart Nebula is like a cosmic garden, constantly planting the seeds for future worlds.
That's amazing.
Yeah.
But I want to step back for a second because I've always been curious about how we see the Heart Nebula in different ways. Like in some images, it's this vibrant red, but then others have these blues and greens. What's the difference?
Ah, you've probably seen images using what we call the Hubble palette.
Hubble palette.
Yeah, it's a technique where we assign colors to the light emitted by different elements, even if those aren't their true colors.
So it's like a false color image, but on purpose.
Exactly. It helps us see where different elements are concentrated. It's like creating a roadmap of the nebula's composition.
So we can see where, say, oxygen is versus hydrogen.
Precisely. Now, if you want to see the nebula's true colors, you can capture it using traditional RGB imaging, which will show that stunning red hue standing out against the blackness of space.
It's incredible how different techniques can reveal so much. It makes you realize the Heart Nebula is more than just, well, a heart shape.
Oh, absolutely. It's part of something much larger, in fact. It's embedded within the Cassiopeia OB6 association.
Cassiopeia OB6. What's that?
It's a vast star-forming region spanning hundreds of light years. So the Heart Nebula is just one piece of a much grander cosmic canvas.
Wow, that puts things into perspective. I mean, it's already so vast, and it's just one small part of something even bigger.
The universe is full of surprises like that.
It really is. And the Heart Nebula, with its, well, heart shape, it's captured people's imaginations for ages.
Yeah.
There's something about it. Almost too perfect to be natural.
It's definitely got a poetic beauty to it. And it's cool that the red glow, that comes from ionized hydrogen, that's a fundamental element for life.
So not just a pretty picture, but a reminder that we're all made of
stardust. We are literally connected to these cosmic events.
And that makes you wonder, have you ever looked at the Heart Nebula through a telescope?
I have, and it's an incredible sight. Of course, you can't see it with the naked eye. It's too faint. But with a telescope and a special filter, a hydrogen alpha filter. You can see the nebulosity in amazing detail.
A hydrogen alpha filter, that makes sense. It really brings out those emissions we talked about.
Exactly. It's a must-have for nebula viewing.
So it's something even amateur astronomers can enjoy.
Absolutely. Just find a location with minimal light pollution. It's best viewed during the fall and winter in the northern hemisphere, and you'll be amazed by what you can see.
Okay, so that's going straight on my astronomy bucket list. But we've talked about the Heart Nebula's beauty, how it forms, and even how to see it. But I'm curious about its future. What happens to a nebula like this over time?
Well, that's where things get really interesting. Remember those stellar winds and supernovae we talked about? They play a huge role in how the nebula evolves. It's a very dynamic environment, you know? It's not static. It's constantly changing the Heart Nebula. In a few million years, it'll look completely different from how we see it today.
So we're seeing just one moment in time.
Exactly. It's like a snapshot in a very long cosmic life.
What I find fascinating is this idea that the nebula is almost like a self-sustaining ecosystem. The stars are born there. They live out their lives, and then when they die, they get back to the nebula. And that creates the conditions for more stars to be born.
Precisely. It's this beautiful cycle of cosmic creation and renewal. As destructive as those supernovae seem, they're actually essential. They seed the nebula with heavier elements, which are the building blocks for planets and, well, for life itself.
So it's not just a stellar nursery. It's a potential cradle for countless future solar systems.
Exactly. And it really puts things into perspective, doesn't it?
It really does. I mean, it makes you realize how everything is connected. Those supernovae, they may seem catastrophic, but they're essential for life as we know it.
That's a great point to bring up. Without them, we wouldn't have the elements that make up our planet. Our very bodies are made of stardust.
That's pretty mind-blowing when you think about it. By the way, I was reading that the Heart Nebula has a celestial neighbor, something called the Soul Nebula.
Ah, yes, the Soul Nebula, also known as IC 1848. It's another emission nebula. It's located pretty close to the Heart Nebula.
It's still in Cassiopeia.
Yep, still in Cassiopeia. They're often photographed together. Actually, it makes for a pretty stunning cosmic vista.
So the universe decided to create a celestial Valentine's Day card.
You could say that, I guess.
Okay, so back to the Heart Nebula for a second. I'm curious. If we could rewind the clock, what would we see? How would it have looked, say, a few million years ago?
Oh, that's a fun thought experiment. If we could travel back in time, a Heart Nebula would definitely look different. The stars in Melat 15 would be even younger, more energetic. They'd be blasting out more intense radiation and stronger stellar winds.
So even more powerful than what we see today.
Oh, yeah. And the nebula itself would be denser. It wouldn't have those really defined structures that we see now. Those are sculpted over time.
So what we see today is just a snapshot. It's constantly changing, evolving over millions of years.
Exactly. And in a few million years, it'll look different again. The stars in Melat 15 will continue to evolve. Some will end their lives in those spectacular supernovae, and that will enrich the nebula even further, trigger the formation of new stars. It's a never-ending cycle.
It's like looking back in time to understand our own cosmic heritage.
Yeah.
You know, our solar system, it formed from a similar cloud of gas and dust billions of years ago.
That's a great point. By studying the Heart Nebula and other star-forming regions, we can gain insights into the processes that led to our sun, or Earth, ultimately to us.
So the Heart Nebula, it's not just a beautiful object to admire. It's a window into our own cosmic past and future.
It is. And it's quite remarkable how something so vast, seemingly so distant, can actually evoke such personal feelings of wonder and connection.
That's a good point. I mean, it really highlights how we're all connected to these cosmic processes in ways that we might not even realize. Like, we are all made of stardust.
We are, and that's what makes astronomy so captivating. It's a constant journey of discovery and wonder. With each new observation we make, we uncover another piece of the cosmic puzzle.
Well said. Well, as we wrap up our deep dive into the Heart Nebula, I have a question for you listening out there. Knowing that the elements created in the Heart Nebula could one day form new planets and maybe even life, does that change how you view this beautiful cosmic object?
It definitely adds another layer of appreciation for me. You know, when you think about it, the Heart Nebula is not just a pretty picture. It's a potential cradle for countless future solar systems.
Wow, yeah, and to think some of those systems could evolve to support life. Maybe even beings who look up at the night sky and see our sun as part of their own nebula.
That's right. It challenges our perspective, makes us realize that we're just one small part of a much larger story.
A story that's still being written.
Exactly. And we're not just observers, we're participants in this grand, unfolding cosmic tale.
It really highlights how interconnected everything is in the universe.
Hmm.
Well, we've covered a lot of ground in this deep dive. We've explored the Heart Nebula's structure, formation, and evolution.
Yeah, we've talked about its role as a stellar nursery, a place where stars are born, live, and die. And in that process, they create the building blocks of planets and life itself.
We've also touched on its cultural significance and even how to observe it for those wanting to see it for themselves.
Hopefully, we've inspired some of you to go out and find a dark sky location and take a look.
We challenge you to look up images of the Heart Nebula online and consider its place not just in the vastness of space, but also in the context of your own life here on Earth.
Think about those vast distances, those unimaginable timescales, and what it all means for us here on this little blue planet.
What does this cosmic heart tell you about our place in the grand scheme of things?
That's a question we each have to answer for ourselves.
Well said. Thanks for joining us on this deep dive into the Heart Nebula. We'll see you next time for another cosmic adventure. Until then, clear skies.